For those of you that are just starting out programming, basically your program uses two kinds of memory, the stack and the heap. The stack is memory allocated by the compiler. For that, the compiler must know how much memory to allocate at compile time. So we can say that this memory is used for everything that can be known at compile time. For example, when you create a variable of type float like this. Conceptually, we can say that the compiler will allocate 4 bytes on the stack to store x. However, what happens if we need to store an unknown number of floats in an array? Then we need the heap. The heap is just memory we can request from the operating system at runtime. In C++, we can do it like this. The size of the array is hard-coded, which defeats the purpose of the heap allocation, but you can imagine getting the size of the array from other calculations at runtime. Anyway, this program will allocate a space in memory for 10 floats and give back a pointer to that space. With the pointer, we can add values to the array like this. However, we have to remember to delete this memory when we don't need it anymore. Okay, since allocating memory on the heap is already built into C++, why do we need to implement a memory management module? Well, games do all logic and rendering calculations at least 60 frames per second. That's a lot of calculations. So every millisecond counts. It turns out that allocating memory like that can slow things down and cause other problems like memory fragmentation. Also, it can lead to memory leaks. So what is the solution? Instead of thinking about little allocations thousands of times each frame, we can pre-allocate a big chunk of memory at the start of the game. Slice it and distribute it across all our game systems. That way we only request memory from the operating system once, at the start. However, we have to write the logic to slice and distribute this memory to any system that needs it. This is usually called a custom allocator. There are many types of allocators though. I implemented first a linear allocator. This is very easy to write. You have some structure like this, then you write the initialize function that requests the initial chunk from the operating system. As a side note, I use malloc and free to request memory from the system. That's not important. You can view it as new or delete from before, and another function to destroy the allocator. Now the important part. We need a function that consumers of the allocator will use to allocate memory from it. You can do something clever here. For example, implement this function as a template that accepts the type to allocate. That way you can use the type size and alignment to allocate it correctly. However, I'm not going to do it like this here. In a production allocator, you should take into account alignment though. You'll notice a few things. The allocator doesn't support resizing after initialization. In my implementation, I allocate a big enough buffer and call it a day, but you can implement resizing if you want. We are returning a pointer to the space in memory where the allocated type will live, just like before using the new keyword. However, we now control the logic behind it, and we can use our pre-allocated buffer. So do we have to also implement a deallocate function to free memory? Not really. Of course, this depends on your use case for the allocator. In my case, I don't support free memory at specific addresses. Instead, I nuke the entire buffer. So this is very cheap to do. You only have to set the offset to 0. So no allocations will override the previous one. This is useful when using so-called per-frame allocators. These are allocators that are reset at the start of every new frame. As I said, there are many types of allocators. Here are some blog posts that I found on the internet. And this is the current state of my memory management module in my game. In the following weeks, I will continue with more modules.